If you only had a few minutes to understand physical geology, what are the concepts that actually matter? Not the trivia, not the memorized definitions. The ideas that explain earthquakes, volcanoes, mountain ranges, beaches, soil, and even where natural resources come from. That's what this video is about. Today, we're breaking down the most useful concepts in physical geology, the ones that help you read the Earth like a system, not a list of facts. The first and probably most important is plate tectonics. Earth's outer shell is broken into moving plates, and that motion drives a huge amount of geology. Why is this useful? Because once you understand plate boundaries, you can predict where a lot of major events happen. Earthquakes tend to cluster along faults and plate edges. Volcanoes often form where plates collide or separate. Mountain ranges build where plates crash together. For example, Japan sits near active converging plate boundaries, which is why it experiences frequent earthquakes and volcanic activity. Meanwhile, the Mid-Atlantic Ridge is a spreading boundary where new ocean floor is created. So instead of remembering random locations, you start recognizing patterns. Next is the rock cycle. This is the idea that rocks are not permanent, they change form over time. Igneous rocks form from cooling magma, sedimentary rocks from deposited material, and metamorphic rocks from heat and pressure. Why does that matter? Because each rock type tells you something about the environment that formed it. A sandstone might suggest ancient beaches or deserts. A volcanic basalt could point to lava flows. A metamorphic rock might reveal deep burial and tectonic stress. Geologists use this to reconstruct Earth's history. Another essential concept is the difference between weathering, erosion, and deposition. Weathering breaks rock down, erosion moves the material, deposition drops it somewhere new. This sounds simple, but it explains a lot of the landscapes you see every day. Rivers carve valleys by erosion, deltas form where sediment is deposited. Soil begins when rocks are weathered into smaller particles. This is also useful in real life. Farmers care about soil formation. Engineers care about erosion risk, and city planners care about sediment movement near coasts and rivers. Then there's geologic time. Earth is about 4.5 billion years old, and many processes are incredibly slow on human timescales. That matters because it changes how you think. Mountains don't rise overnight. Canyons aren't usually carved in a weekend. Even small changes repeated over millions of years create massive results. This idea helps explain why slow processes are often the most powerful ones. Closely related is uniformitarianism, the idea that the same natural processes we see today also operated in the past. In other words, the present is the key to the past. If rivers can erode rock today, then ancient river deposits likely formed the same way. If volcanic eruptions happen now, similar eruptions shaped old lava layers too. This is one of geology's most powerful tools because it lets scientists interpret ancient rocks and environments using modern examples. Finally, a huge part of physical geology is understanding how water, wind, ice, and gravity shape the land. Glaciers scrape valleys into U-shapes. Rivers form floodplains and meanders. Wind builds dunes. Gravity causes landslides. This is useful because it explains hazards and resources at the same time. A landslide-prone slope matters for construction. A river floodplain may have fertile soil but also flood risk. A glacier-carved basin might hold lakes and sediment deposits. So if you remember just a few concepts, make it these: plate tectonics, the rock cycle, weathering and erosion, geologic time, uniformitarianism, and landscape processes. Together, they give you a framework for understanding how Earth works. And once you have that framework, geology stops being a list of terms and starts becoming a story about a planet that is constantly changing. The most useful concepts in physical geology you need to know is just one small part of physical geology. If you're interested, our full free physical geology course is linked in the description.